All right, add two numbers. Okay, now 3, 2, 1, start. Okay, so you're given two non-empty linked lists representing two non-negative integers. The most significant digits come first, and each of their nodes each of their nodes contains a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. What if you cannot modify the input list? In other words, reverse the list is not allowed. So the most significant digit comes first. It's the head. So, but usually the problem with this question is that if you would do it normally without programming, if you want to add two numbers, right? If you want to add two numbers, you start from the least significant digits and add all the way up. But the problem is, right now, this question, we need to start from the beginning. So, if we want to do it every time from the end, like if we want to do it, because this is linked list, so every time we want to add the least significant digit, we'll have to go to the end of the linked list, add it up. Next time we add it, we have also need to go to the linked list to the end again. So this case is n times n, which is not very convenient. Well, actually, it's n times n squared plus m squared, because for every node we have to iterate n times. So can we do it just with n plus m? I'm thinking maybe we can do a stack. Right. So if we can put all of these nodes into a stack, into two stacks respectively, we'll be able to add the node from the least significant digits. Okay, let's do it. So stack list node stack 1 node stack list node stack list node stack 2 new stack list node. Okay, so we have two stacks right now, and for right now what we need to do is to push all the nodes into the stack. So so you know what? Do we need to keep track of L1 and L2? Because I was thinking if I iterate the list with this head, then I will lose the head. So, but for now, we will have while L1 is not equal to null, we will push the stack we'll push the node into the stack, and then L1 is equal to L1 dot next. So same thing, we're gonna copy and paste this. So if L2 is not equal to null, L2 as stack 2 push L2, and L2 will proceed to the next node. Okay, so now we have the stack. So, and we need, so since the most significant digit is on the left, so we need to create a new linked list to keep track of the sum of the single digits. So, and also we need to have a sum, a temporary sum. Okay, so we need, well, let's do this first. So let's do linked list. Let's do linked list node. Result. Well, you know what? I'll create dummy is equal to new dummy new dummy list node 0, right? So, and then list node is equal to dummy. Okay. All right. So stack, let me check if stack can be empty or not. What's the, so to determine if a stack is empty, do we use size or empty? Empty, perfect. Okay, so while st1 empty, well, this is not empty, and st1, st2 is not empty, then what we need to do is we're gonna pop the stack. So if st1 empty, how are we doing with time? 7 minutes. If st1 is not empty, we're gonna pop. So okay, first of all, we need a sum. So the sum is to add on to the sum is the addition of the single digits of these two stacks. So sum is equal to 0, right? So if stack 1 is not empty, then we will pop this node, and also we will get the value of it. So sum will be add to pop, okay? And same thing. Same thing. If st2 is not empty, then sum will add st2 pop dot value. Okay. So if it's not empty, then we will add it to sum, and we will create a new node. Node dot next is equal to, wait. You have to reverse it because you're adding the least significant digits, right? So I feel like you also need to stack, but can you reverse a linked list? Let me check. Is there a reversed? No, there's no, because this is a whole new linked list. So I feel like I have to use stack 2, right? So you know what? I don't want to reverse the linked list at the end. So I would just use the stack. You know what? I'll reverse the linked list at the end. I'll reverse it just to challenge myself, right? Why not? So that I can use less space, because if I use stack and I'll also use list node, it's but it doesn't matter, right? I mean, for what? Right? You know what? I'll use the stack so that I'll use a stack. Okay. This is fucking stupid. I feel like I don't have time this time. Okay, so stack is result, and then result is push, right? So we're going to push a new node, new list node. Sum divided by 10. Well, actually, it's mode 10, right? So this is the new sum. This is the new node. So after we push this into the new node, into the new stack, we're going to update the sum. Okay. So this is pretty much done. And at the end, so after that, after that, one of them might not be empty. So while this is not empty, we're gonna keep popping. Wait. So I'm sorry. This is OR. So we don't have to do the while loop again. So until they are both empty. So now it's time to do the trick. So while result empty, result is not empty. Node dot next is equal to result dot pop, and node is equal to node dot next, and we are going to return the dummy dot next, right? So we're going to keep adding to the top. So anyways, at the end also, we need to see if sum is equal to 1. If it's 1, then we need to add it to the stack. So result push new list node. One. Okay, so if sum is equal to 1, then push 1, and then at the end. So I think this is good. So first of all we create 2 stacks, 3 stacks, and then list node is for the results. So sum is equal to 0. First of all, we push all the node, we push all the linked list. We push all the nodes from this linked list 1 to stack. I think I just scared the dog. Stack 1, and we push all the nodes from linked list 2 to stack 2. And then, well, they are not empty. We are going to pop So pop is value, and then add it to sum, and then push it to the result stack. And then update sum if sum is equal to, okay, you know what? Time up. I'll just go for it. Okay, it looks good to me. Accepted. Perfect. Okay, great. So it was kind of complicated, but no, it was easy question. So anyways, thanks for watching. See you next time.